CATIA PLM Express for mold design and manufacturing is a dedicated, integrated solution for high-level automation of the user process. It allows to capture and reuse best practices, to minimize repetitive operations, and to focus time and expertise on high-value tasks. The design part received by the mold designer is a plastic handle for the door of a car. This part has been designed with another system than CATIA V5 and is provided as an IGES file. The result of the IGES conversion is a set of unconnected faces. This result is analyzed to easily check and repair geometrical defects and to join together unconnected faces into a single, clean, closed surface. The result of a morpho simulation shows that the injection process will induce a significant deformation of the handle hole from round to almost elliptical shape. The mold designer can visualize and compensate it by applying a counter deformation to the nominal part. The result is editable and can be refined by additional simulations if needed. The counter deformed part will be used to define the mold tool. The mold designer will therefore create a round tool in order to get the right molded part. The moldability of the part is analyzed and the mold rears of the part are extracted. Core side is shown here in red, cavity side in green, and slider contact rear in yellow. Creation of the parting surface is accelerated thanks to dedicated capabilities, while allowing the user to keep control of the surface strategies in order to monitor shape and quality. The mold tool for the handle part is created from a user-defined assembly template stored in a catalog shared inside the company. The template contains the 3D assembly definition, mold plates, rough insert blocks, various standard components like leader pins, screws, ejectors, and so on. This definition capitalizes experience from past projects, thus allowing the mold designer to avoid starting the new mold tool from scratch. It is easily instantiated and adjusted to fit the handle part, like for example the size and shape of the inserts, the number and position of ejectors. The slider unit is a custom assembly component defined as an internal standard in the company. Like simpler components coming from market providers' catalogs, it is easily positioned and adjusted, and the corresponding drillings, including associated colors and tolerances, are automatically created in the surrounding elements. The tool template includes not only the 3D assembly, but also drawings, which are a starting basis to help reduce the amount of work to define the 2D sheets for the new project. Thanks to the single CATIA V5 infrastructure, the machining operations are natively defined and integrated in the same tree structure as the geometry. 3-axis operations like roughing can be conveniently checked by video simulation. The 2.5-axis machining module automatically analyzes the part to identify the list of holes and automatically creates groups requiring similar operations. These patterns are based on user-defined criteria like diameter, tolerance, or color. A template-based approach is possible. Expertise gained from previous projects has allowed to define a machining process. Appropriate machining strategies, operating conditions, and corresponding tool resources are thus automatically applied to the hole patterns computed previously. The resulting program can be optimized, for example, to minimize the number of tool changes. A key feature of CATIA V5 is the capability to perform integrated machine simulation thanks to the single infrastructure holding the part geometry, the definition of the NC tool paths, and the synchronized ISO code driving the machine. This allows an early detection of errors, like collision between the workpiece and the tool. This unique approach avoids lengthy back and forth exchanges between different softwares, like what other CAM systems have to do. This example has illustrated how CATIA PLM Express mold design and manufacturing solution enables to define a faster, more reliable, and more efficient process.